In this section, we're going to be removing dual inline packages with the vacuum extractor. Notice that these dip components have 2 rows of flat leads. Each of the leads will have either a tapered or flat shoulder. This is designed to hold the component away from the surface of the board for cleaning purposes. For flat leads, the vacuum tip needs to be sized so that the width of the component lead will fit inside the desoldering tip. And like before, the tip should not hang over the edge of the land whenever possible. We can perform an optional flux application onto the component leads on the solder side of the board. Again, positioning of the board will be based on your personal preference. We're ready to start at one of the corners. You'll often find that 2 of the corner leads will be partially clinched to hold the dip in place prior to soldering. Typically, these partial clinches can be desoldered with the vacuum extractor. Starting on the clinched corner lead, we'll angle the vacuum tip parallel to the lead, then push the lead inside the tip as the solder melts. When the solder joint is molten, we can bend the lead upright and position the tip squarely onto the land. After the entire joint is melted, we'll move these leads back and forth rather than around in a circle. Then activate the vacuum and continue drawing air through the hole to cool any residual solder. After we remove the tip, continue the vacuum in order to draw the solder all the way into the storage chamber. In order to avoid potential heat damage to the board, we'll need to skip around rather than desolder in a continuous line. Some people prefer to desolder the corners first. Then they proceed to alternate back and forth in this same pattern. Others simply skip every other joint and work their way around twice until the job is completed. Either way, keep repeating the operation until all of the joints are desoldered. Hopefully, the component should come out of the board without any difficulty. Remember never to pull it with any force. If it doesn't come out easily, you'll need to figure out which leads have sweat joints. You can do this by gently moving each lead until you find the one that doesn't move back and forth. Then we'll add solder to that particular joint in order to transfer heat all the way through the hole. Always give the joint a few seconds to cool off after you add solder to avoid overheating the hole. Now you can desolder the hole once again, and the dip should be ready to come out. That covers the removal process for dips and other flat-leaded components like D-packs or power transistors.